Welcome to the first video lesson of the year. Today we're going to be talking about logs. So we're going to be doing a lot of log problems. Usually this lesson is more interactive and you guys do an activity, but since I'm gone today, it's just going to be me working through all the logs. So you should have your guided notes, hopefully, so you can follow along. So we're starting off with just solving basic exponential and log equations like you did last night on the homework. So for the first problem, if we want to solve for x, we want to get rid of that e. So we know we can take the natural log of both sides. So we're left with x equals natural log of 12. If this were on a non-calculator section, you would just leave it like that. If it was on the calculator section, you could plug it in and it should give you about 2.48. For the next problem, I know with logs our natural base is 10, so I'm just going to write in our base of 10. So we used that arrow trick last class, so 10 to the 7th power gives me x. So we've got 10 raised to the 7th power gives me x. So you can leave it like that, or we know that this is going to be 10, and then you're going to attach a bunch of zeros. So I'm just going to leave it like that for now. The next one, getting rid of that natural log. So if I rewrote this, I could rewrite it as log base e x cubed equals 20. So using that arrow trick again, e raised to the 20th power gives me x cubed. So e to the 20th power gives me x cubed. And then to get rid of that cubed, I can just take the cube root of both sides. So cube root. So in your calculator, you could either type that in, or we could just leave it as x equals the cube root of e to the 20th power if you didn't have a calculator. The final problem of this warm-up section, we've got x to the 4/3 equals 13. So to get rid of the denominator, because I don't like fractions too much, what I'm going to do is I'm just going to multiply this, or raise this to the 3rd power, and do the same thing on the right side. So that makes my 3's simplify. So I'm left with x to the 4th power equals 13 cubed. And then to get rid of that 4th power, I could just take the 4th root of both sides. So we're left with x equals the 4th root of 13 cubed. And once again, you could type it into your calculator, or if it was on a non-calculator section, you could leave it like that. So hopefully that all seemed familiar. The next part should also seem pretty familiar, but just stepping it up. If we're solving equations, it's basically just like solving like x for normal, so we want to isolate that variable. So I'm going to start with adding 5 to both sides. So I'm going to get 3e to the 2x plus 1 equals 27. Then I'm going to divide by 3 on both sides. So we'll end up with a 9. And then to get rid of that e, we can take the natural log of both sides. So we're just left with our exponent of 2x plus 1 equals natural log of 9. And then from there, it's just normal solving equations. You would subtract the 1 and divide by 2. So we would end up with natural log of 9. And then we would have subtracted 1 from it and then divided everything by 2. So we'll put the whole thing over 2. For the other problem, I would usually have you do this on your own, but since I'm videoing, I'll just do it with you. So you'd subtract 3 and divide by 5. So subtract 3, you'll get 5 log x squared minus 1 equals 5. Divide by 5, so we'll have log x squared minus 1 equals 1. We know that invisible base is 10. So I can use my arrow trick, say 10 to the 1st power gives me x squared minus 1. So we've got 10 to the 1st power is 10 equals x squared minus 1. I can add over that 1, so 11 equals x squared, and then just take the square root of both sides. So our final answer there is going to be x equals plus or minus square root of 11. Good. So last one in this section. Once again, we would start with dividing by 5. So make sure when you divide by 5, you divide every single part by 5. Don't just do the first part. So we're left with e to the natural log of root x equals 2x minus 3. Then we learned last class that natural log is the same thing as log base e. So this e and this e match, so we can get rid of these. So we're just left with root x equals 2x minus 3. So if we want to get our x's isolated, we need to get rid of this root. So I'm going to square both sides. So keep in mind that's not just doing 2x squared and 3 squared. We've actually got to do 2x minus 3 times 2x minus 3, and then boil that out distributing. So we're left with x equal, oh, that's a bad equal sign. X equals 4x squared minus, let's see, we've got minus 6, so minus 12x plus 9. And then we can subtract over that x, so we'll have 0 equals 4x squared minus 13x plus 9. And then we can try to factor that. For time's sake, I'm going to factor it for you. So if we factored that, it would turn into 4x minus 9 and x minus 1. And then if you solve those, this one will equal 9/4. This one will equal 1. So when we end up with two solutions like this, and we've squared both sides, we need to go back and check our answers to make sure that they both work for the equation. So because for time's sake, I'm going to let you know that 9/4 does work. But if we were to plug in 1, because that one's easier to plug in, we've got 5e natural log of root 1 equals 10 times 1 minus 15. So natural log of 1 is 0. So this is like e to the 0 power. So this is turned into a 0. So e to the 0 power is 1. So 5 times 1 is 5. Over here, we've got 10 minus 15, so negative 5. So that means that 1 does not work. So this is not a possible solution. So only x equals 9/4 works. Excellent. So this kind of illustrates that idea as well. If you've got an original like x equation, and then you've squared both sides, so if you square that, you get 4, but then you go back and you root it again. If you take the square root, oh, this should have been squared. If you take the square root of that 4, our answers are positive and negative 2, but that doesn't fit the original equation. So that's one of the reasons we have to always go back and check our work. So now we would have done an activity, but since I'm gone, we're not going to, so I'm just going to tell you what it is. So if you flip to the back of your notes, there is 4 boxes that I wanted you guys to put the properties in. So these are our 4 properties. So our first property is that when you have a log and you're multiplying things within the log, you can split that up into 2 separate logs with that same base and an addition sign in the middle. So basically multiplying pairs with addition. Or vice versa, if you'd started with addition, you could go backwards and turn that into multiplying, as long as they have the same base. Division, same thing, it pairs with subtraction now. And you can go back and forth with those. If you saw a minus sign with the same base, we could just divide. With exponents, when we've got an x or our value raised to an exponent, we can bring that exponent up to the front, and then you're going to have that value in the front of your log instead. Same thing goes the other way. If you had a number in the front of your log, you could take it the other way and bring it up here and make it your exponent. So those are 3 important properties. The 4th one is change of base rule. So this is especially important if you don't have a calculator, so you can illustrate these. So if we've got log base BA, you can split that up into a log of the A value divided by log of whatever your base is. Same with natural logs, it works the same way. So this is useful for when you don't know what, like if this is, both of these are base 10, so sometimes that can help you figure out what these are without even using the calculator. If you want to pause on this slide and write down all your properties, these are good ones to know. All right, so using those properties. If I want to rewrite both sides of a single log and then solve, I'm going to start with trying to use those properties. So we've got addition, which is like multiplying. So I'm going to multiply these together. So I'll have log x times x squared is x cubed minus log 4. On this side, I've got this 2 that I know I can bring over here and make an exponent. So it'll turn into log x squared plus log 7. I can take this one more step, and I've got a subtraction sign, so I'm going to divide. So I'm going to have log x cubed divided by 4 equals log, we've got adding, so we're going to multiply, so 7x squared. So then a really nice property is if we've got logs on both sides and there's nothing in front of them, so I'm going to call that a clean log, we can simplify them out. So that's beautiful. So all we're left with is x cubed over 4 equals 7x squared. If we wanted to simplify that, I could multiply by the 4. So I would get x cubed equals 28x squared. And then subtract this over to put all the x's on one side. Here we can factor out the x squared. And finally, we would set both parts equal to 0, so you would end up with x equals 0 with a multiplicity of 2 in case you care, and x equals 28. Once again, we've got 2 answers. We should go back and check to make sure they work. So if I'm checking it, if we plug in the 0, log of 0, can you take a log of 0? No, there's an asymptote there. So right away, 0 is not going to work. And to save time, I'm going to let you know that 28 does work. 28 is good. The next one asks us to solve for x using change of base rule and our calculator. So we've got 2 different bases, so that's not helpful. We've got actually 3 different bases because this is log base e. So what it means by change of base rule, that's the one if we go back here. Nope, not back there. If we go back here, change of base rule is where you can split it up into a fraction. So I can split this into log 17 over log 3. And this splits into log 100 over log 4. Natural log of e, we know goes away, so we're just left with x there. At this point, we could just get x by itself, so we just have to subtract that over. So in the end, we're left with log 17 over 3 over log 3, minus log 100 over log 4 equals x. If this was on a non-calculator section, you could leave it like that, or you can literally type all of that in, and you're going to get about negative 0.74. So that's the way we could use change of base rule. We're about to run out of time on this section of the video because I only have 15 minutes. So I'm going to stop it now, and then I'll record the next 4 problems in another video.